Hey guys! Alright, now we're going to do section 6 of chapter 6, which is solving exponential equations. So you've already learned about your exponent rules, your logarithm rules. We've manipulated everything, we know about the natural log and everything, so now we're going to throw it all together and we're going to learn how to solve any type of exponential or logarithmic equation. So we've got two ways that we can do this. One way is to graph both sides of the equation and find the intersection point, but we're not going to do that. Okay, we're going to use algebra, so we're going to use algebra and logarithms. So my first problem is 7 to the m equals 14. Okay, so if I want to solve that, the first step that I'm going to do is I'm going to take the log of both sides. Remember that anything I do to one side I can do to the other side, and that includes take the log, okay, or get rid of the log. So now what I can do is I can take this power and I can move it down to the front using my logarithm and power rule. So I'll have m times the log of 7 equals the log of 14. Okay? Now if I want to get m by itself, I can divide out log of 7. So I'm going to do that to both sides. Okay, so now I've got m equals the log of 14 over the log of 7. Okay, so I can just plug that into my calculator, and when I do that, I get 1.36. All right, next question. I've got 17 times 4.5 to the n equals 90. Okay, so the first thing I'm going to do, I want to get this part by itself, so I'm going to divide out this 17. So now I've got 4.5 to the n equals, I'll just leave that as 90 over 17 so I don't have any rounding errors. Okay, now the next thing I can do is take the log of both sides. Remember that anything you do to one side, you have to do to the other side because we have an equation, which means that both sides are equal. Okay, so now I can move this power down to the front. And then I'll notice that to get n by itself, I need to divide by the log of 4.5. So in my calculator, I can plug in log of 90 over 17, make sure you close that parenthesis, divided by log of 4.5, and that's going to get me n equals 1.108. Okay, so that's the answer to that. All right, the next problem, we've got a sum of money is deposited in a savings account with an annual interest rate of 3.75%. How many days does it take for the initial deposit to double if the compounding occurs in the given manner? So we've got if we're compounding monthly or if we're compounding continuously. Okay, so let's just start with the one where we're compounding monthly. Remember that if we're compounding monthly, we need to use our compound interest formula, which is A equals P times 1 plus R over N to the NT. Okay, so I know that my interest rate is 3.75%, so my R is going to be 0.0375. Okay, and I am looking for how many days it takes to double, okay, the amount that I deposited. So this is a little tricky because normally I just plug in P, R, N, and T, and I get a number out. But in this case, they're asking me to figure out the number of days it takes in order to actually double my investment. Okay, so that means that I can kind of make up some numbers. So what I'm going to do is I'm going to say that P is 1. And if P is 1 and I want to double that, that means A is going to be 2. Okay? And I know that my N value is, I'm compounding monthly, so that N value is going to be 12. Okay, and what I'm doing is I'm trying to solve for T. Now remember that in this formula, T is in years, and they're asking me in days. So at the end, I'm just going to have to convert that back into days. All right, so I've got 2 equals 1 times 1 plus 0.0375 over 12 to the 12t. Okay? So what I'm going to do is I'm going to start by figuring out what this is in the parentheses. So if I plug that into my calculator, I get 1.0031. Let me just make sure that's right. Yes. So this is 2 equals 1.0031 to the 12t. Okay, so now I'm to a point where I can take the log of both sides. And after I take the log of both sides, I have a power here inside logarithm, so I can move that down to the front. Okay, and again, I'm trying to get t by itself. So if I want to get t by itself, that means that I want to divide out 12 and I want to divide out the log of 1.003. So I'm going to have log of 2 over 12 log 1.0031 equals t, and just plug that into my calculator, and that'll give me t equals 18.51. Now remember, that's in years. Okay, so they wanted it in days. We know there's 365 days in a year. Don't worry about leap years. Okay, so we're going to take 18.51 times 365. And you should end up with approximately 6,757 days. Okay, so that's how long it's going to take for your initial investment to double. All right, we also want to do the same problem, except this time we want to compound continuously. Okay, so remember, if you're compounding continuously, you're going to use your PERT formula. A equals PE to the RT. So we're going to do the same thing, it's just this time we're using PERT. So I'll say this is 2, this is 1, e to the 0.0375 t. Okay, now my problem here is that I have a base of e, okay, which actually isn't a problem because I have a natural logarithm which has a base of e as well. So I'm going to take the natural log of both sides this time instead of taking the common log because there is an e in this function here. So I've got the natural log of 2 equals the natural log of e to the 0.0375t. Now again, I can move that down. So I've got natural log of 2 equals 0.0375t times the natural log of e. Now real quick, let's think about what the natural log of e is. Okay, the natural log has a base of e. Okay, so natural log, has a base of e, so I'm taking it to the e, and let's just say that equals something. If I were to write that in exponential form, that would be e to the x equals e. So what would x be? It'd just be 1. So that means that the natural log of e is just 1, so I can just cancel it out. I can just get rid of it. Okay, so now I've got the natural log of 2 equals 0.0375t. I can divide both sides by 0.0375. And that'll give me t. When I plug that into my calculator, I get 18.48. Again, remember that's in years, so now I need to multiply that by 365, and that gives me 6,747 days. So my compound interest formula is going to be a little bit faster by about 10 days, which is not a lot. Okay, next problem, I've got a radioactive isotope, and I'm going to be talking about half-life. So when you're thinking about a half-life, you need to think about how fast is that decaying? Okay, so if I have a material, let's say I have 10 grams of some sort of material, and I want to think about, is that decaying monthly, yearly, or continuously? Okay, well, the obvious answer is that it's going to be decaying continuously. So that means that you have to use your PERT formula. So we've got A equals PE to the RT. This is the formula that you use for half-lives, okay, because they decay continuously. All right, so remember, A is the amount that you actually get out, so that's kind of like the amount left. If I know that something has a half-life of 6 days, okay, and I want to find the percent left after 10 weeks, okay, let's just say that my T value is going to be 6 days. Okay, and if I have a half-life, that means that I have half of the original amount that I started with after 6 days. So let's just say that A equals a half, P equals 1, and T equals 6. Okay, so I can use that to figure out my rate of decay. I can figure out how fast am I going down. Okay, so I've got 1/2 equals E to the R times 6. Okay, if I want to solve that, I'm going to take the natural log of both sides. Again, I'm taking the natural log because I have an E in there. So I'll have the natural log of E to the 6R. If I move that 6R down, remember the natural log of E just cancels out, so I'm just going to leave it out of there. So I've got the natural log of 1/2 equals 6R. I can divide both sides by 6. And I get R equals, gotta plug it into my calculator real quick. Negative 0.1155. Okay, so that's my rate of decay. You'll notice that it's a decay because I've got a negative value here, so that means I'm going down. Okay, and now I want to figure out how much is left after 10 weeks. Okay, so I'm going to use this R value, and now I'm going to solve for A, and I'm going to plug in some different values here. So I'm going to use my PERT formula, except now I know that my R value is negative 0.1155. Okay. Now my T value, it says 10 weeks, but notice over here when I used half-life, I was talking about days. So 10 weeks, okay, that's going to be 70 days. So for my T value, I'm going to put in 70. For my initial value, I could either put in a 1 or I could put in 100, depending on whether I wanted to convert to a percent at the end or not. I'm just going to put in 1. Okay, so I'm going to have 1 e to the negative 0.1155 times 70, and that's going to equal the amount left. Okay, so when I plug that into my calculator, I get 3.076 times 10 to the negative 4. Okay, so that's the amount that's going to be left at the end of 10 weeks, which makes sense that it's such a small amount because after 6 days, only half my material is left. So every 6 days, it's decreasing by half. Okay, so I'm going to have a really, really small amount left. Okay, notice that if I rewrite that, that's going to be 0.0003076. Okay, if I write that as a percent, that's going to be 0.03%. Okay, so the answer is going to be 0.03%. Okay, there's one more thing we need to talk about, and that's the change of base theorem. The change of base theorem says that for all values of a, b, and c, for which logarithms exist, we can say that the log of base b of a is equal to log base c of a over log base c of b. So basically that c can be any base. So you get to change the base to whatever works best for you. So I would say change it to 10 or change it to e, because those are the ones that we can plug in on our calculator. Okay, if you change it to a base of 6, that's not really going to help you much because you can't plug that into your calculator, so you won't be able to solve it. Alright, so let's do some of those problems and we'll estimate them. The first one is log base 5 of 100. So remember, we can't plug that into our calculator because our calculator only does base 10 and base e. So let's just say, let's do a base 10. And I'm going to use my change of base formula, so I'm going to say log base 10 of 100 over log base 10 of 5. Okay, then you can just plug that into your calculator and you get 2.86. Okay, the next one, I've got log base 2 of 2/7. So again, I can just use my change of base formula. So I'll have log of 2/7 over log of 2. If I plug that into my calculator, I get negative 1.8. Okay. Next one I'm going to do is log base pi of e. Alright, notice that whenever you see that e in here, it's probably a good idea to use the natural log instead of the common log, just because generally we can cancel that stuff out. So this will be the natural log of e over the natural log of pi. Natural log of e is just 1, so this is just 1 over the natural log of pi. If I plug that into my calculator, I get 0.87. Alright, so that's everything for Chapter 6.